Okay, I wanted to show a new feature I just configured in Vim here. Well, now I've got my harpoon to these different buttons. So I can switch between all these different files now. But the feature I wanted to show was what I can do now is go to the top of a function and hit, what is it? If I toggle ZA will toggle the fold. So I can collapse different blocks of code now. And then, so like we can close, like let's say we just kind of close all these functions that we're not worried about right now. We probably want player swap open. So now we could kind of navigate a little bit easier through here. Yeah, we'll leave reset board open because that's kind of where we initialize a lot of values. And we'll leave our player swap open because that's where we reinitialize a bunch of values. And then we'll open up every function that we're kind of working with now. And then we can also come in here and we can kind of, nope. I guess I thought it would allow us to close comments like this, but it kind of just zips everything. But we could kind of zip certain things like that. Yeah, okay. So I guess I want to figure out a way to kind of collapse comment lines better. But we can need this open. No, if move type place, okay. Okay. So a lot of the stuff we know we won't be tweaking, we can kind of just collapse so we can navigate easier. And kind of collapse these movement events. Because we don't really need to worry about moved events right now. We're just doing the wind detection. So I'm wondering if we can just kind of come in here. See, I guess this is not what I thought it would do. I thought it would just collapse this one block of the else if, but it kind of collapsed everything. Which isn't as useful to me. Yeah. I'm wondering if there's a way we can use this function to collapse commented sections. to kind of mimic what we had going on with our Sublime. But we can't forget to save our folds, otherwise Vim will just erase them. So what we can do is, if we go to a spot where we've got a lot of folds, like up here, we can make sure to fold save, which runs our mark view function, I guess. And then if I did this right, we can exit and then when we reload it, it'll start off with no, I wanted, it'll start off with no folds, but we can do our shortcut to fold load, and then we've got them back. So this will allow us to kind of navigate easier. So I was excited about figuring that out, but it still needs some work. Ideally, we'd be able to close some else if functions and whatnot. But now we can cycle through our whole code base a lot easier now, and manage it better. So let's take a look at where we're at. Yes, if our mouse is in the middle and we run that, it won't crash. Okay, so we've got this. Why do we call it H column? Horizontal column. Horizontal column stone control check. Okay. I'm thinking that we want to rename some stuff from yesterday. Now, I want to change the left orthogonal middle stone match right here. So our function is called left orthogonal middle stone match, but our variable is called left orthogonal match middle stone. So I just wanted to make sure that was the same. So we can go here and we can actually modify every one of those at once. So left orthogonal middle stone match. Now we substituted those all, but we need to go to our occupant class, which is one of these buttons here, and change it here as well. So if we run our last command, we can do it the same thing. We say left O middle stone match, and then substitute that. Now we want to make sure we write that out. We want to make sure we write out this one as well. And then seems to be working. we need to, what's the next step here? Now, I'm thinking we actually need to do a lateral match function, because part of our notes here, part of our, where is our notes? Yeah, so this lateral connect, I think we want this as a function because we need to do a lateral connect between our second row and our... Okay, so lateral connect is a function that is gonna take in a grid, and it is gonna check for a left match of that stone control, a right match of that stone control, but also check if it's not a left and a right match on that very stone. It's gonna go through every possible vertical match it has and check for a connected right orthogonal match to go with the left orthogonal match. So it's just part of us proving that there's gonna be a road. But we need to use this. The function's gonna be complicated because I'm thinking of a way to do it that is very verbose and explicit, that I want to figure a better way of doing, but I can't quite wrap my head around how to do it without crashing, because as you can see, anytime we index a value of our grid that is off the value of the grid, it just crashes. So that means anytime we're doing a lateral connect on a stone that is in the very top row or the very bottom row, that searching for the vertical connect will index a no value, therefore crashing us. So my current idea is to, in our lateral connect function, to kind of start with our topmost stone with a left connect. And if that stone is a row of 1, then we're first going to check the right connect, and then if it's no right connect, we check beneath us and see if that one is not only stone control, but if that one has a right connect. And then we can move on to the next first and last connect with the same function. But we need to kind of do every possibility, because, for example, if we're a row of 3 on a stone stack control of white, we need to check for a left connect, and if we have a left connect, we check for a right connect, and if we don't have a right connect, we have to check all of our up positions first. So if we could be only having a left connect in a middle stone row of 3. Yeah, that's a very middle spot. And then right above us, there is a stack control of a white, but there's no right control, right orthogonal match on that one right above us. But the one above that, the very top row, could have also a stone control, stack control of white, and that one could have a right orthogonal. So we have to be able to determine, we need to be able to run all the potential code for any given input of an occupant. So if it starts at the top, we only check that grid and below. If it starts at the bottom, we only check that very row and above. And then if it's the ones in between, we have to check every possible combination, which is where the crappiness comes in, because there's no smart way to, I'm not thinking of a smart way to do this, of knowing how to be able to check every potential one above us and the next orthogonal spot without hard coding it in. Because here, maybe I'll illustrate. So if we have a stone road that looks something like this, our horizontal column stone control check is true because there's a white stone in every column, so we know there's a potential for a road. But the tricky part here is we have to start, since we're starting with left control first, since there's no left control on this grid, we know that there isn't a road just yet that connects us over here. So we'd go through to the next one, and we'd see that this middle stone has a left connect. Therefore, we would go and check. Since it's in the bottom, we would only check the squares above us. So in this scenario, we would have, this would be a road both horizontally and vertically, but just for this sake of argument and figuring this out, middle stone would have a left control, therefore we need a check above us for a right control. So it will be like, oh, okay, so this is our stone control, so let's see if this is our right orthogonal match, and it is not. So let's check the one above us, and if it is a stone control of us, let's check the right of us of a match, and it isn't, so let's check another one. If it's our control, which it is, let's check the next one, which it isn't, and then we're still looking for that right orthogonal match, so we're going one up from there. And then, since this one is a stone control of white and it has a right orthogonal match, then we can move on to the last connect and the first connect part of our algorithm. But, you know, there's got to be a better way of doing this. My reasoning was to start with the left match because we know if there's a road, we know we need to both have a right match and a left match, and those two need to be connected vertically. And this is where it's tough. Because we could say, we could check for either side of an orthogonal match and then check the surrounding stones for the opposite side. But I feel like that's going to be more confusing than it's worth. So I think we need to start with all of our stones with a left orthogonal match first. And we'll start at the topmost one, and in our algorithm we'll cycle through all of the highest possibilities first, all the rows above it first, before we move on to the rows beneath it. It's really daunting. It's like I know there's a better way to do this, but I'm not sure. The good news is, even if we explicitly do all the scenarios for our certain middle stone match locks, we could reuse that for the first connect and last connect to determine. Actually, no, it would be different than that, because we just need to check the right side of our middle right orthogonal match. Okay, so it's even simpler than that, so we wouldn't need to use that function again. So maybe we don't write a function. So right now we're cycling through the middle stones. And if there is a stone in any of the rows of our middle column whose stack control is white, and whose stone to the left of us is a left orthogonal, or that's how we would lock in our left orthogonal middle stone match. So we need we need to be able to determine a right orthogonal middle stone match, meaning there is a same stack control directly to the right of our middle stone stack control. And only if there's The vertical match is what screws us and makes it so complicated, but we have to figure it out. So I think I'm not going to do the right orthogonal middle stone match just yet. I think we're going to start with the vertical checks, because we wouldn't even get to a right orthogonal match unless there is a vertical check passing, which we need to know. We need to know the grid. We need to know the grid of our left middle stone match. So difficult. How do we save? How do we save the grid positions of our middle stone matches so that we can only cycle through all of our middle stone stack control objects or occupants? Well, we can have a variable. We can have a variable that holds an integer of 1 through 5. See, no, because it needs to handle multiple potential row indices for our middle stone stack controls. So maybe we just have an array of numbers. If it's a 0, it doesn't have stack control. If it's a 1, it has stack control of a white. If it's 2, it has stack control of a black. And we can kind of populate this array with the correct value for the stack control ID. So the whole idea behind this is we need to be able to know which row of our middle column occupants, we need to know which row to run our lateral connect logic for, because it's already so many different checks that we only want to check anything if it's it would have to have a left stone connect in order for us to check whether or not there is a vertical stone connect with an ultimate right orthogonal match. Jesus, okay. So the whole idea here is once we know the one to the left of us has a stack control of a white as well, we would populate our array at the current I index with a value appropriate to the stack control that we're trying to determine. Or so if we have what should the array be called? We called it stack control ID, but it's not really that simple. It's left orthogonal middle stone match ID, because this table is only populating an array based on whether or not we have a left orthogonal middle stone match. So if we have an array called left orthogonal middle stone match ID, we would modify the ith value of that array to be equal to the stone control of that middle stone, because we would ultimately need to run a lateral check on that occupant. So we can say grid I, grid I2, no, I3, be the middle stone. And it'd be the middle stone's stack control. Come on. Come on, dude. Okay. So we need to populate a 5-table array of we need to populate a 5-table array that is named left. How do we go to the beginning of a line in BIM? It's 0. So if we visual mode it up, visual mode it up and highlight this, we know we need to populate this array with, we'll say 0, I'm gonna write this down. We'll say 0 is a nil stack control, meaning there's no stone in there. And then a 1 would be a white stack control. A 2 would be a black stack control. So let's go ahead and give us this array of 5. We only need 5 because we know we need to run lateral connects on potentially every row of our middle column. So we only need 5. So if we go to the top here, when we make ourselves a board, we can say that we need this left orthogonal, no, it's left, here, I yanked it. Left orthogonal middle stone match ID. Now we need to get, we can hard code this in. We can say it's an array of 5, or a table of 5. And we can say that array gets all zeros. Okay. Now we need to also take this wiping or nullifying upon every player swap, because once you have the possibility to change stack control of the grid, we need to recalculate all of the IDs for that middle column. So we'll put this in our player swap function as well. So we'll just put it right here as well. So now, I don't think we can do this like this. We have to pass in it as a table. So we can, insert mode, Table. Table. Okay. So once we have a table of 5 values, I think that'll work. No. So we've initialized our array to 0 for each of them. Now we need to populate them with the appropriate value. Right now we're only doing white stack control, so we can only assign them based on our white. And what we're doing is we're saying that that array at the ith index, which would be the row that we have a left orthogonal match, we assign our left orthogonal middle stone match to true, and we also assign, see, and it's not this simple. This would store the string white instead of the number 1 here. So instead of doing the color here, we would say that we just want to assign it to be equal to 1 because we know it's a white stack control at this point. And then hopefully this gives us an array. Hopefully this populates our array table with a 1 at the index of whatever row we have a left orthogonal middle stone match. And we're also flushing our table upon a player swap, but we don't run our player swap in our place move type place. So we actually need this also to go in our move type place once we click on a non-occupied grid. So right here, after we update stone control, we need to assign it empty. No. We don't need to assign it empty here. We need to I think we need to flush it before we run our where are we even assigning this? We're assigning it on a left orthogonal middle stone match. So I think we need to flush it right before our middle stone match function, because our orthogonal middle stone match is what's actually going to give it the proper values, but we need to make sure it's flushed so it doesn't have any potential old bad values in there. So we need to run it right before our orthogonal middle stone match, which we're not even running. Left orthogonal middle stone match. Where are we even running that? We're running it right here. in our determine horizontal win. Okay, so right before our determine horizontal win, we need to flush those values. So yeah, we can do it. I'm curious what this orthogonal match flush is doing. Actually, we could probably put this line of code inside that function. Let's take a look at our orthogonal match flush function. Yeah. Okay, no, we would need to flush it no matter what, because this is only, actually we could do it. Yeah, we could do it here. We just have to do it outside these for loops. This will flush any left orthogonal middle stone match field to false. So what we can do is, instead of having it right here, we can take it and put it in our orthogonal match. And we can do a shift N. Yeah, it's right under this flush, so we can say we need to put it right here. I don't get why it does the weird tabs and stuff, but okay, so we flush. Not only are we flushing the booleans of our left orthogonal middle stone matches, but we're flushing the IDs of those arrays as well. And then after we flush them, we run our determine horizontal win function, which then populates our left orthogonal middle stone match IDs with, because we're doing this middle stone match, which is populating our match IDs with an index of 1 if a stack control is white. So I'm going to see if we have enough space on our 692 play state. Right here. Assignment, not equality. So we just delete that. What are the odds that the bug was right on my cursor? Okay, left orthogonal middle stone match ID is a nil value. So we're crashing at 57. What is going on? I'm just trying to go to the 57th line and I can't figure it out. There we go. Okay, so it crashed here, saying that this was a nil value, so we can't really declare a table of 5 that big. Apparently, so I think we need to say left orthogonal middle stone match ID gets an empty table, and then we're able to populate that table with 5 values. I think that's how you do it. And then once there's 5 values in that table, then you can index into them. So it looks like that's working, and it looks like we have enough room on our debug 4 to actually type our array there. So I'm gonna just visual mode, highlight this variable, yank it, and go to the bottom of our file into our debug 4, and we'll put in a new line that is gonna be this line essentially. Bank, put, delete this so that we can paste it in here. And we'll say I don't know how to paste without that new line in there. But for now we'll say that it's left orthogonal match middle stack middle stone match ID, and we'll print out a whole table. So we need to concatenate 5 values here. The first value is going to be the left, this one at index 1, and then we need to concatenate it with all of them. So right here we'll say, instead of the comma being here, we need to insert mode, put insert mode, a space. Come on, man. Insert mode, space, put to string match ID. Now we need a 2, and then we can do the same thing. We want to concatenate it with the space though. So, well, I guess we can just have them all hugging there. It doesn't really matter. But let's see if just those two. We should be getting 2 zeros at this point if we save this code and run it. 772. Yeah, we just forgot to delete this. Okay, we need it on the new line so we can actually read it. So our new line. Zero, zero. Nice. That's working. What that's saying is the 0th row, which is this one. No. It's saying the first row, which is at the 0, is a 0, which is a nil. The second one, which is a 1, is a white stone with a white stone to the left of it. So I think that's working so far. So let's continue to put our... That's not what I wanted. We need to shift copy all this, yank it, go here. And we need to put it in there. This is a 3. We need to put a 4 in there. This is a 4. We need to put a 5 in there. This is a 5. Make sure we've got our comma, write it out. Now we should have an array of 5 values that only get populated to 1 if the stone to the left of us is a white stone and the stone in the middle is a white stone. So let's see. We need a parentheses here. Okay. So we've got an array of 5 values. Now, if we had a white stone, actually, let's do this different. If we had a white stone in every spot in the middle, they should still be all 0 because none of them have a white stone to the left of them. What? Why are we... I don't get why that was happening. But see how they get a 1 if the one to the left of it is a white stone, and then if we were to move a black stone on top, we could undo that, but that's not working just yet. So see, I thought that since we flush it, we're not flushing it on a move type move yet. I don't get why it's wanting to print out this table value. It only seems to be on the match ID of 5. Why does it do that? Why does it do that? How come? Why does the 5th index get set anytime we place a white stone in the middle stack? ID. Doing that. I don't get why. Why is it? Why is it that the 5th array in that table gets set to a table value? When do... I don't know what would cause that. Now we're doing this, oops. We're doing this on a reset board. I feel like we can just do that. I don't think that'll fix our problem, but maybe it does. Why would the 5th array of our table get set wrong upon a move type placement? So if we go and see our move type place right here, when we click in an empty spot, yeah, would be in this orthogonal match flush. And we do that after our stone control update. We don't do a stack control update though, which is what we need to do. I think we need a stack control here. I don't get it. I'm curious if we have another. Oh, is this what it is? I think this is what it is on a player swap. We do this, which we need to, yeah, I think this is the problem. I think we just need this. Reset its table like that, and then now we won't have that weird table. It's still there. What is going on? I thought for sure that was the problem. This is it. This has got to be it. There we go. We reset it to an empty table, not an actual table. I don't actually know what that array indexing was doing. Oh, it was putting a whole table at our fifth element, and our fifth element reference. Okay. That's it. Okay, it's working correctly now. So unless there's a white stone directly to the left of our middle white stone, that value is going to be 0 or 2 if it's a black. But we have at least the match ID for white stones populated. Now we need to fix it for any time we move a stone on top. Because if we move a stone on top, oh, it's working. It's working. So if we put a white stone on top, it should go back to 1. And it does not. Okay, I think that's totally fixable because we only do, I need to write this down. So we need to flush our matches before we swap, which I think we do, but we do not left orthogonal middle stone match. We don't do that. We need to do that after we flush on a move type move. And I think we do that. We just have to make sure we do this same order of operations for our move type. Move type move instead of move type place. So we take a look at our move type move. We do this where we say orthogonal match flush, determine horizontal win. And then as long as we do those two things, we should update. We should update that value in a move type move. So We can run this in the move types once we swap players. Actually, yeah, right before we change our movement event. Yeah, we don't really care about it before we've dumped our first movement, so we don't need it in a movement event 2, but we would need it in a movement event 4. No, because that's just locking in the stones in our hand, and then once we actually dump it and move it, once we hit enter, this is it. Yep, so we do a determine horizontal win here, which is correct. So we would just need to place it right here. Okay, so let's go ahead and visual mode, highlight this to the next word, yank it. Now we need to do this before our next determine horizontal win. We could probably just put this in a determine horizontal win function. Yeah, it's hard to say. I'm going to double check what's in this. And it's... See, this isn't even right. We need to also do a left orthogonal middle stone match. But actually we don't, because that's in our determine horizontal function. Which... I think it's okay to have this 2 different functions, because... Let's just go find our next determine horizontal win. And make sure there's an orthogonal match flash right above it. So we'll say V for visual mode. And we want to jump back to the beginning of our word. What is going on? Why are all these blue? these blue? Okay. This bugs me, man. Why is it like this? Why is this rendering this wrong? See, it's because it's not colored here. Why is it not colored here? There's got to be a thing in our LSP we can... This really bugs me. I don't know why it's doing this, dude. What the heck? What is going on? This is really disheartening. Why does it do this? You're fine up here. It's gotta be a highlight thing. It only messed up when I started highlighting stuff. There's got to be some... See, why would the color turn on again down there? How do you clear all searches? Control L? It's back. It's back. No, it isn't. My Control L is set to a different key binding. Sorry, it's a disaster, guys. Angel search. This was really annoying. If Vim can't be reliable like this, it's gonna be unreliable like this. I don't want to work in it. It's driving me crazy. Oh my god. It's still busted. First one that it's messing up at. But it looks fine. I really don't know what's going on and it's bugging me. We just lose highlighting and then it's all jacked up. tuple X should uninstall it, then we can try to reinstall it. This is unforgivable, man. This was my fault. I'll concede, but it shouldn't be this busted. This is just unforgivable, man. $1337 is where it's not working. Literally, there's one wrong thing right here. Oy, oy, oy. Okay, I guess I'm just stupid. So we've got a 1 in that third row. Now let's see what happens if we move a stack on top of it. It should go back to a 0 once we lock this in. It does. Now it should go back to a 1 if we drop it this here. It does not. There's a scenario where we picked up what if we just put it in our player swap like we thought? We'll put it in our player swap. No, we have to set it before it. We have to set it before it. There's gotta be a time. What movement event was that we did that? It was when we lock in our first movement? No. We locked in our first movement. It's when we dropped our first movement right here. When we press down, press enter. Yeah, it must have been right there. We also gotta do it. Everywhere we press enter. We almost got it. We need to figure this out. Let's figure out what movement event that was when it failed. So it is correct right now. but if we move a stone on top of it, it is incorrect. And then if we move a stone out of it, this is a movement event 4. Pressing enter upon a movement event 4 should flush that and then determine a horizontal win. So movement event 4, pressing enter. We do it, man, we do it. We do it. We're doing it upon an enter press here. We can't just put it in our determine horizontal win because our... No, we probably can. We're doing our left orthogonal middle stone match inside. Okay, so I'm thinking if we put if we flush it right before we do our new match. So unless our stack control isn't working right, this has no reason to not be working. So let's check our stack control. Stack control's white. Stack control should be black, which it is. Now stack control should go back to white here. Which it does. Yet, we're still 0 on the match ID. What is going on? Does our middle stone match even get set true in that scenario? Middle stone match, we're not even printing it. Let's print our middle stone match for the grid. I thought we were. Match ID, but we need to print the middle stone match of our grid. I thought we did this yesterday. I could have sworn we did this yesterday. What? Lordy. Gotta love him. The learning curve is something else on this bad boy. We're gonna be a 7. We're gonna be I think it's this one. Jesus hell. This is ugly and disgusting, and I'm sorry for my awfulness in Vim. Okay. We're printing up the middle stone match. It's wrong. So we flush it, and then we populate it. So anytime we flush it, we go ahead and populate it. So I don't get why it would be 0 there, or if it would be false, because anytime we run it, which a flush, so like anytime we do the flush, we populate it with the match. Except, yeah, except right here in our place state, right here. We need to do it here also. So we can flush it. No, we're running the function there. We're running the horizontal wind function there. So it shouldn't matter that we're doing this. Since we're running our horizontal wind function here, it should be Populating left orthogonal middle stone match. Something's going wrong and I have no idea what. No idea what's going on, dude. See, what's weird is if our ID is 1, that should mean that we put our match to true because we hard coded it in there. So I don't get how our match ID could be 1 and our match field in our occupant would be false. That doesn't make any sense to me. How can we have... Oh, God. Okay, I forgot. Our grid has to... We have to be... This is the same freaking problem I did yesterday, but okay, it is working. It is working there. So let's see if it works when there's a black on top. It should get to false, which it is. And then if we're a black off of it, we're back to true. And our match ID isn't right anymore. We've got the right boolean, but not the right match ID. So why is the match ID not getting reset on a player swap? Let's take a look at what move type we're in. By the time we move that out, which it is a move type 4, by the time we press enter, yeah, we've got the match, but it's not wrong. So move type 4 when we press enter, which we've already checked, but movement event 4. When we press enter, we are determining our horizontal win. But that is for an off-grid ending turn. We also need to do it what if we just... So yeah, if we swap players here, we go ahead and do it, which this is the time that it was incorrect. Are we doing something in our player swap? Let me see if we're doing something in our player swap function. We do reset it to 0 here. So we set it appropriately and then we wipe it. We wipe it right here. Now we don't need to wipe it here. We need to wipe it only when we only need to wipe it when the stone control changes hands. And we're doing that as soon as enter is pressed in our determine horizontal win, and then we repopulate it so we don't need it there, and that should fix it. So we've got the right ID. Now let's see if we put a black stone on top of it. The ID should go to false, and we shouldn't have a match anymore, which is correct. And now if we move a stone out of it, our match should become true, and our match ID would hopefully get populated with a 1. And it does. So we got it figured out. That was the problem. Holy crap. Okay. So what we did today was, why don't we take a look? Yeah, why don't we just take a look at our git diff here? So we gave ourselves, we renamed our match field. I don't remember taking out CS height. Let me check constants real quick. Oh lordy, this is not what I wanted. Let me check constants real quick. It's fine. I don't know why it's popping up like that. Okay, so what we did was this is hard to read, man. Nope, I want it. See, I don't like that it's so dark. It should be bright green for the git diff, which I don't like. So maybe we open up another terminal and we do a git diff there. That's easier to read. We renamed our match variable. We populate that table with empty values. We flush those values and then populate them upon a stack control, a left orthogonal middle stone match. We populate that table with a code depending on the stack control. And then we added our flush to our horizontal win function so that we can then populate. So we flush it, then populate it so that we don't have to do it every frame, but we do it only upon a change in stack control. And then we updated stack control in this play state, which I don't think can hurt, and it seemed like it was missing. And then we added some debugging. I really did have that code. I deleted it somehow, but we had to re-add it, and then we got 2 new debugging. So we'll get add with a commit message saying we populate left orthogonal middle stone match ID for white stack control. That's basically all we did. But that's a big step. So now what that allows us to do is we can run our lateral connect function on only stones that have a left connect. So now we can start implementing what I was ranting about at the beginning, which is cycle through all the possibilities for a vertical connect and then look for our match, our right match, so that we can go on and check our first connect and last connect and ultimately determine if there's a road. So that's one step of our step 2 done. It's just going to take a while, especially if I keep making mistakes like I've been. But okay, well, I'll see you guys tomorrow, and we'll hopefully we'll start implementing our lateral connect function now that we've got a variable to detect which stones we need to run that function on.